Hey everybody, welcome back to another video lecture about Chemistry 107, and we're beginning Unit 4. And in this video we're going to be talking about Chapter 24 and the Octet Rule. Now, the most important thing that we've kind of already dealt with in Unit 3 is this thing right here, is that electrons determine the chemical properties of an atom. Okay, and so the periodic table is organized in a way that has similar electron configurations kind of grouped together in columns on the periodic table. So if we take this one step further, what we know is the noble gases are unreactive. And I say for the most part because we can force just about anything to happen. And so we can force a noble gas to react if we want it to. But the idea is that they're very unreactive. And if we count how many electrons a noble gas has, it has 8. If we take neon, for example, it has 1s2, 2s2, 2p6. It has 8 valence electrons. And then we can take argon, which would be 1s2, 2s2, 2p6, 3s2, 3p6. Okay, and again, it has 8 valence electrons. So that number 8 is very important in chemistry. It actually is, we have a rule called the Octet Rule that says when an atom has 8 electrons in its valence, it's going to be very, very, very stable. And the way we imagine this is once it has 8 electrons in its valence, it then ends up looking like a noble gas. It doesn't become a noble gas because we haven't changed the number of protons or neutrons, but it looks like a noble gas in terms of the part of the element that is most reactive, or is the part of the element that determines reactivity. So, atoms want to have 8 valence electrons. Okay, this is what we call the Octet Rule. Okay, and so if we look at a periodic table, we can figure out what's going on here with these two statements. So I have the Webb elements periodic table pulled up, but I can actually draw on this at this point, so that's why I brought it up here. And keep in mind that part of this is there's a stair step here. I know that that's not a very good stair step, but you get the idea that all of these guys are metals and these guys are nonmetals. So I think it's easier to talk about the nonmetals first. If we take a look at nitrogen, okay, nitrogen has 7 electrons. Okay, it wants to have 8 in its valence, and right now it has 1, 2, 3, 4, 5 in its valence. So what we can do is, or what happens is, nitrogen is going to gain 3 electrons. Okay, it's going to gain 3 electrons so that it can look like neon. Okay, so if it looks like neon, it's going to gain 1, 2, 3, and so we can predict that nitrogen will have a 3- charge when it forms an ion. It's probably not going to have any other charge except for 3-. Sulfur, same thing. It wants to look like argon. It has 6 valence electrons. 1, 2, 3, 4, 5, 6. So it's going to gain 1, 2 more electrons. So sulfur forms a 2- ion. And so like this, we can predict the charges of the elements on the periodic table. Let me do another here. Okay. So if we take fluorine, okay, fluorine has an electron configuration of 1s2, 2s2, 2p5. It has how many electrons in its valence? That's right, 7 electrons. And the octet rule says that we want to have 8. So in order to get to 8 electrons, it's going to gain 1 more electron. And that's, notice what we see on the periodic table. It gains 1 electron to look like neon. And so we get fluorine that ends up with a 1- charge. Let's take a look at the metals now. This is a little different and can be a little more challenging to see. Let's take a look at sodium. Sodium has an electron configuration of 1s2, 2s2, 2p6, 3s1. We can tell that because it's in this column. That's the 3s1 column. Now, sodium wants to have 8 electrons in its valence. And remember, the valence is the outermost shell that contains electrons. So there's, in this case, it has 1 valence electron. Now, sodium could gain 1, 2, 3, 4, 5, 6, 7 to look like argon. But watch what happens. This is what makes it fun and interesting and obvious, is that what if we lose 1 electron here? What if we just lose the 1 electron? What ends up now becoming the valence? Look. Now the outermost shell is the second shell, and notice that there are 8 electrons in its outermost shell. So sodium ends up losing 1 electron, not gaining, but losing 1 electron to become sodium 1+. And that's true with many of these elements throughout the periodic table. Okay, so we can do the same thing for, let's say, calcium. Calcium has a Lewis dot structure, and maybe it even is better to look at the abbreviated structure, or the abbreviated configuration. It has an electron configuration of argon and then 4s2. Well, if we want calcium to look like argon, we can just get rid of those 2 electrons, and then so we can get calcium with a 2+ charge. So the point is depending on where the element is on the periodic table, we can predict what its charge is going to be. And the prediction is based on the octet rule, where atoms will want to have 8 electrons in their valence in any way that they can get them. And so thus we can predict the charges on the elements on the periodic table. So that talks about, that is the octet rule, and have a great day.